topic for today is all about the properties of logarithm. So we'll be discussing different properties of logarithm. Okay. So to start with, we have here this one, the property number one. A logarithm of 1 of any base is always equal to 0. Okay. Example. Logarithm of 1 base 7, this is always equal to 0. Okay, another example. Logarithm of 1 base 3, this is always equal to 0. This is the first property of logarithm. The second property of logarithm is a logarithm of a base a is always equal to 1. Let's have, for example, a logarithm of 7 and the base is also 7. This is equal to 1. Okay. Another example, a logarithm of 3 base 3, it's always equal to 1. That is property number 2. The third property of logarithm is this. A logarithm of a raised to the power of x base a is always equal to x. For example, we have here a logarithm of 8 raised to the power of 2 and the base is 8. This is equal to 2. Okay. For example, a logarithm of 5 raised to the power of 3 base 5, it's equal to 3. That is property number 3. The fourth property of logarithm is this. Number a raised to the power of the logarithm of x base a is equal to x. For example, you have 7 raised to the power of the logarithm of 5 base 7 is equal to 5. Okay. Another example, 3 raised to the power of the logarithm of 4 base 3 is equal to 4. Okay, so this is property number 4. The fifth property of logarithm is also called as the product rule. Okay, it is the logarithm of mn base a is equal to the logarithm of m base a plus the logarithm of n base a. Okay, so we have here, for example, the logarithm of 3x base 3. This is equal to logarithm of 3 or log 3 base 3 plus log x base 3. From the previous property, okay, we know that the logarithm of 3 base 3 is equal to 1, and this is plus logarithm of x base 3. This is the answer. Another example, we have log 4b base 2. So this is equal to log 4 base 2 plus log of b base 2. Okay, so this is the fifth property, or we call it the product rule. The sixth property of logarithm, or they also call it as the quotient rule, it is the logarithm of m over n base a is equal to the logarithm of m, the numerator, base a, minus the denominator, the logarithm of n base a. Let's have an example. We have here a logarithm of x over 2 base 3. This is equal to the logarithm of x base 3 minus the log of 2 base 3. Let's have another example. Log of 1 over 3y base 3. This is now equal to the log of 1 base 3 minus the denominator, a log of 3y base 3. From property number 1, we know that the logarithm of 1 of any base is equal to 0. So this is now equal to 0 minus, now since this is a product rule, okay, property number 5. So let's apply property number 5. Let's simplify this. Okay, minus the log of 3 base 3 plus the log of y base 3. Okay, so it's now equal to, let's eliminate 0. It's negative. Okay, now from property number 2, we all know that the logarithm of a base a is always equal to 1. So therefore, this is 1 plus log of y base 3. Let's distribute the negative sign. So our final answer would be negative 1 minus the log of y base 3. So this is for property number 6. The seventh property of logarithm, or it is also called as the power rule, it is the log of m raised to the power of x base a is equal to x, that is the exponent, multiplied by the logarithm of m base a. For example, we have the logarithm of y raised to the power of 3 base 2. It is equal to 3 times the logarithm of y base 2. Let's have another example. Logarithm of the cube root of 5x, cube root of 5x base 5. So this is equal to logarithm of log of 5x raised to the power of 1/3, because this is cube root, okay, base 5. Let's apply the power rule. This is now equal to 1/3 times the logarithm of 5x base 5. Now, since we still have here a product rule, property number 5, so we need to simplify this. So that is equal now to 1/3 times the logarithm of 5 base 5 plus logarithm of x, log of x base 5. As we all know, that the log of 5 base 5 is equal to 1. So let's just simplify further. So this is now equal to 1/3 multiplied by 1 plus log of x base 5. This is now our final answer.